announcements. So let me do that before I forget again. Awesome. So one of the ways that we hope to drive excellence in the field is through our monthly webinar series. And we try to choose monthly topics of interest to the EE community with goals of sharing and sparking ideas, improving practice, and connecting with one another. I'm sure everyone's been on a lot of webinars lately, but we have been doing this for the past 3 years or so. And like I said, we've been trying to up the webinars in the last couple of months to meet all of the needs of sharing more ideas with one another. And I just wanted to mention a couple upcoming events that we have. So next Tuesday, we have another webinar about Latino Conservation Week and how your organization can get involved. I think they've had to make some changes to that event, which is scheduled in July. So they'll share information on what that event is going to look like and, again, how your organization can get involved. So that would be a great one. We also have a lot of conversations going on with the EE community around the COVID-19 outbreak. And so we have a calendar up on the main page, or a link to it from our main page on our website. There's calls, kind of check-in calls. There's calls for practitioners, calls for adapting program models, calls for EE managers and, you know, retaining staff. So hopefully you can find a way to connect with one another during this time. And then finally, I really want to emphasize that our awards for excellence in environmental education are due next Friday, April 24th. So we would love for you to think about those programs that have inspired you in the last year, those educators that you know of that deserve to be recognized by their community, and submit a nomination. Again, all of this information is up on our website. And if you have any questions, feel free to email me. I'm happy to help. Also, just a big thank you to our webinar series sponsor, Marathon. They've been sponsoring us for a couple years now and make it possible for us to put together these webinars. So we appreciate their support over the years. And then finally, you probably don't need a tutorial in Zoom at this point, but if you could just keep your line muted throughout the presentation today, at least during the part where Melanie is going to be speaking, that would be great. It just helps us reduce background noise. We mostly use the chat function to communicate. So if you've got and that's located at the bottom of your screen for most people, that's a good way that you can ask questions to Melanie and I. If you've got technical problems, which I hope you don't, but you can ask those there. You can communicate with one another, post additional resources or thoughts regarding the webinar today. So definitely use that chat function to communicate with us and each other throughout the webinar. And then finally, before I introduce Melanie, I did want to just start with a land acknowledgement. So the history of the United States and Colorado includes a history of purposefully trying to erase Native American culture. So it's important whenever we can to center in the place where we are and the history that brought us here, wherever in Colorado you are today. What we know as Colorado today was the traditional home of the Apache, Arapaho, Cheyenne, and Pueblo tribes, Shoshone tribe, and the Ute Nation. And so I want to share a small part of that history right now. So when gold was discovered in the 1850s, white settlers arrived in Colorado in large numbers and began asserting their right to the land. The Meeker Massacre in 1862 resulted in the expulsion of the Ute Nations to southwestern Colorado. And in 1864, the Sand Creek Massacre resulted in the deaths of hundreds of Arapaho and Cheyenne people, and soon after these nations would be relocated out of Colorado. The Southern Ute Indian Tribe and the Ute Mountain Ute Tribe are the two federally recognized tribes that have their current headquarters in Ignacio and Toyac, Colorado. Approximately 50,000 Native Americans live in Colorado today, and their rich cultural history is highlighted each year at the Denver March Powwow, featuring over 1,600 dancers. So there are many ways to practice remembering the history of Indigenous peoples, by reading books by Native authors, by including cultural history and programming, by recognizing that their culture is alive and vibrant today, or by doing land acknowledgements whenever you can. And so as environmental educators, I invite you to think about how you can incorporate land acknowledgements into your work. And with that, I want to introduce Melanie Armstrong. Melanie Armstrong teaches in the Master of Environmental Management program at Western Colorado University and directs the Center for Public Lands. She is author of Germ Wars, The Politics of Nature and America's Landscape of Fear, and co-author of Environmental Realism, Challenging Solutions. In 2018, Armstrong founded the Center for Public Lands, a hub for cross-boundary work and study which aims to infuse a new generation of land stewards with talent, vision, and energy to meet the challenges of a rapidly evolving social and ecological climate. Before coming to Colorado, she worked for 15 years as an interpreter and environmental educator with the National Park Service. And so I will pass it on to Melanie. I hope she's ready. I just kind of threw her in here today.
We can do this. We're flexible and adaptable in these days, right?
Yes, I think we're getting better at that at least.
I feel like I love the high patience level as well. So thank you for that. I'm going to try to share my screen. Oh no.
We see it. We see your slides.
But I see my slide and everything just froze up. And this happened the last time I did this, and it's really embarrassing. Like I can't advance my slide.
Well, you know what? Sometimes there's a button on the lower left that has little arrows. Sometimes I have to use those. I'm not sure if that's...
I do not have a cursor right now, which is the bigger issue.
Yeah, I feel like technology always comes to...
It's always at this moment, right? Okay, wait, there's maybe a cursor back. Wow.
Is there a secret keystroke for present mode, like control something?
So here's that again. And I was trying to move into present mode. All right.
Oh, I think you got it.
We got a slide now showing?
We see it.
Okay. And it looks normal to you, not present mode.
Nope, yep, it looks full screen.
Woo. Technology. I'm going to bring up the chat box again because I would love to be able to watch your chats if I can. Try to keep an eye on that as well. All right. So thank you. Thank you for the introduction, Lisa, and thank you for inviting me to spend this hour with everyone today. I am a huge microbe nerd, as one would have to be to write a dissertation on microbes. And so it's always really exciting for me when I have the opportunity to just dive in a little bit deeper and talk with people about microbes and why they matter. And I'm afraid that I slipped into my history teacher mode, and what I prepared isn't hugely interactive, but I hope to leave a lot of time for a discussion at the end and a chance to hear your ideas and responses, because I'm really excited to learn from this community as well. And like I said, this is my favorite thing to talk about. So I look forward to hearing your ideas, and I will try to pay attention to the chat box too if questions come up, or Lisa, please feel free to interject at any point in time. But I have one interactive moment at the beginning here, and maybe you saw the answer to this as I was trying to get my screen shared, but if not, play along here. So we have 4 creatures on the screen here. We have the South China tiger, a smallpox virus, the Guam kingfisher, and the West African black rhinoceros. And I'm interested to hear your thoughts. Go ahead and type them in the chat box of which of these organisms is not like the others. Which is not like the others and why? No one want to hazard a guess?
Well, I think the 2 mammals and the kingfisher are extinct.
All right.
although the rhinos might possibly still be around. And
All right, so
smallpox, we've eradicated it in the world, but I don't know that it's extinct.
all right. We're pushing on it here. Definitely some other ideas around vertebra here. There's a visibility issue going on, a size issue. But Betsy's getting at what I was getting at here, which is around extinction. And I'm actually going to highlight the West African black rhinoceros as the one that is different, because it is the only organism on here that is formally extinct. The rest are extinct in the wild, meaning that they only exist in captivity. So the South China tiger and the kingfisher do continue to exist in captivity. And while smallpox, as you pointed out, was eradicated in the wild, it does still exist. When it was formally declared extinct in 1980, when no living cases could be found in humans on the planet, all of the nations that had smallpox that they were doing research on or collected gathered those stores together and sent them to 2 storage facilities, one in the CDC in Atlanta and the second at the equivalent of the CDC in what was then the Soviet Union and now in Russia. So you could maybe make a case that smallpox virus is also extinct in the wild, although it does continue to exist. So today I want to share a history of microbiology with the hope that taking the long view can, if not ease panic in the current moment, it can maybe give us perspective and maybe even optimism for how we will weather this current pandemic. I'm not going to talk at length about my case for why talking about microbes is important in environmental education. I talked about that on our professional PD day with CAEE, and there's a link of that video that we can share. But I'm also happy to have a longer conversation about why I feel like this is important for environmental educators to be well versed on and sort of take up this conversation, if only because of our role as the primary source of educators among adult populations and people who are sort of actively trying to understand their relationship to the environment as human beings. So really quickly, there's a lot of kind of bad information out there around microbes right now, and I think it's important to understand people's credentials. So I come to this from a background in environmental education. As Lisa mentioned, I worked with the National Park Service since 2001. And while I was working with the Park Service, I went back to graduate school and pursued a PhD in American Studies, which means that I'm not a microbiologist. I have no formal training in microbiology, but I'm really interested in studying culture and cultural issues as well, in particular human-nature interactions and how our governments are built around particular ideas of nature. So I've taught in geography and history, environmental studies. I have an interest and a passion for scary things in nature, and microbes really fit into that. I've been telling people as they ask how I'm doing during this pandemic, I tell them that sitting in my home in my pajamas reading about microbial disease all day long is pretty much what I did from 2005 to 2010. So it feels very deja vu to me. But that was when I was working on my dissertation, which led to the publication of this book, Germ Wars. And now I teach at Western Colorado University in the Master in Environmental Management program. I also chair the Center for the History of Microbiology with the American Society for Microbiology. So I attend microbiology meetings every year, although not this year due to the pandemic. But I go with my computer open and I Google everything because the science is still way above my head. So what I'm talking about today is really based upon that history knowledge and understanding that history of our human relationships to microbes. And so a few key ideas that I hope to develop through the presentation as your guide for our conversation today. I think it's important to recognize that as far as sciences go, microbiology is really a young and growing science. It's not as established as many older disciplines, and I think that leads to some particular approaches in how microbiology is done, which I'll talk about in a few minutes. A second key idea that global public health actions, they really do save lives. And I think that's an important thing to remember, but we'll see through history that those global actions can take many different shapes and sizes. And education, which I'm going to argue is environmental education, includes environmental education, does influence the outcomes of those public health actions. And finally, this idea that I won't get into too much in the presentation, but I'm very happy to elaborate on my ideas on this topic, is that the role of microbes on our planet, in our environment, are very complex. So why talk about history? I think that the events of the past, they really do set the direction for microbiology. They've shaped our current science and our public health systems. And it's really amazing to me to watch how that becomes so evident to the public right now. And so I want to argue that we can better thrive in the present if we can see how we came to be here. So I'm going to cruise through about 350 years of microbiology history to illustrate these key ideas. And while microbes have their own long history, I want to start at the moment that microbes became visible to us. We don't see microbes except using technology. They were made visible to us in the late 17th century, and that changed the world. And imagine for a moment, if you will, a world where no one knows that microbes exist. Think about how your knowledge of microbes shapes your interactions every single day, particularly in this moment. And now try to take that knowledge away. How would our lives be different than they are now? So I'm going to start in the 1600s, and unfortunately the dates here, I'm always looking at the end of the century, the late 1600s. And I'm going to start with a button maker named Antoine Leeuwenhoek. He was a tinkerer and was the person who invented the first made-at-home microscope. These are his drawings, his designs for his microscope, and a portrait of him. And in 1676, he took a droplet of water and put it on his microscope plate and looked at it and described for the first time microbes. He said, an unbelievably great company of living animalcules. Think about that word, environmental educators. It's one that ought to be in our lexicon today. Living animalcules, as swimming more nimbly than any I have ever seen, in such enormous numbers that all the water seemed to be alive. Can you imagine how it would feel to take water for the first time, not expecting to see anything in it, to look at it through your own homemade microscope and see things moving around? Then Leeuwenhoek sketched those. He put ink to paper and captured a likeness of the rod-shaped Motobacterium and oral cocci, reporting what he saw to the Royal Society of London. And he wrote dozens of letters describing the bacteria he'd seen lurking in rainwater or dredged from a beer vat. He ran around scraping plaque from people's teeth, and he wanted to find more and more and more microbes. And page by page, Van Leeuwenhoek and other microscope users revealed a natural world that was invisibly entwined with human bodies. And the microscope produced a new category of nature, these little animals living inside our very bodies. And long before these microbes were connected to infectious disease, they were painted as monsters. They were foreign creatures moving unbidden through human spaces. And new fears were created and new relationships with the world were made. And making microbes visible made social intervention possible, even necessary. Humans had to decide how they would react to these new natures, both as individuals and part of the new social order that was rising alongside in this era of revolutions in science and industry and government. So I'm going to travel forward a century, but at first I want to set the stage for human disease during this era. And around this time, smallpox was the deadliest killer of humanity. This is in the 1700s, and this is a quote from a member of the English gentry. He says, "The smallpox was always present, filling the churchyards with corpses, tormenting with constant fears all whom it had not yet stricken, leaving on those whose lives it spread the hideous traces of its power, turning the babe into a changeling at which the mother shuddered, and making the eyes and cheeks of the betrothed maiden objects of horror to the lover." Lord Macaulay's description of England during a smallpox epidemic captures the grim fear surrounding a disease that killed a third of the people it touched. Think about that in terms of what we're looking at today. 35% was the mortality rate from smallpox. The virus had power not only among the infected, but also over those who fearfully anticipated infection. And it was indeed a gruesome disease. Lesions began in the mouth and grew until they ruptured and spewed virus into the body through one's own saliva. And the pockmarks that characterized the disease erupted late in its course, but the marks left behind lifelong scars on the bodies of those who survived infection. Indeed, the variola major virus has been responsible for much of the suffering, blindness, scarring, and death in human history. Historians have credited the European conquest of the Americas to the virus that invading armies left behind on their corpses. With little genetic immunity, native populations were gravely impacted by smallpox. And scholars estimate that along with measles and flu, smallpox killed up to 95% of the native population of the Americas. Smallpox killed more people in history than any other disease. And I set that gruesome stage to understand and give context to what happened next, and perhaps shed some light on our current circumstances and what people are willing to do to stave off infection. And even when they don't know the cause of disease, our social practices were designed to mitigate contagion. So we had quarantine and funeral rites and religious traditions that prevented the spread of infection from dead bodies or food or other human beings. So even before we could see microbes, we were changing our social behavior because they existed, because of the ways that disease spread, even though we didn't fully understand it. But because the risk of dying of smallpox in this era was already extraordinarily high, it's no surprise that smallpox motivated the development of some of the earliest medical preventions of disease. And variolation, which is pictured here, became a common practice. And this method produced some level of smallpox immunity by rubbing the liquid from a smallpox pustule over a scratch made by a needle on the arm of another human being. So they would take live smallpox from pustule and put it in, like, scratch it into someone else's body with a needle. And the procedure itself, like just having a variolation practice done, was fatal for 1% to 2% of those who were treated. So think about that. I mean, that's better than a 35% fatality from contracting smallpox, but still a mortality rate that's about like what we're looking at with COVID-19 currently, just from the variolation process, from hoping that you don't contract the disease itself. There were a couple other methods of variolation. In China in the 15th century, powdered smallpox scabs were inhaled through the nose. In Africa, mothers would tie a cloth around a child's smallpox-covered arm and then transfer that cloth to a healthy child, which would give them a mild case of smallpox. But the hope was that the child could survive the mild case when they were young and protect them from getting a more severe and deadly case down the road. So variolation was also credited with tipping the scales of the Revolutionary War, and a little bit of disease trivia here. During the American Revolution, about 90% of the deaths in the Continental Army were due to disease, many of which were smallpox related. Variolation was pretty common in Europe by then, and most British troops had some level of immunity. But in the Americas, fear of contamination, which I would say was justified with a 1% to 2% fatality from the procedure itself, had limited variolation practices. And on the 6th of January in 1777, George Washington ordered the inoculation of all of the forces that came through Philadelphia. And it was a huge undertaking, but Washington was working to recruit people to his army, and people were afraid of joining the army because they were afraid of those close quarters and contracting disease and dying. And so Washington ordered a response, and within a year, the Army had built 11 hospitals that were purposed just for variolation. And with few surgeons and fewer medical supplies and absolutely no experience, Washington conducted the first mass inoculation of an army during the height of war. And for the duration of the revolution, none of his regiments were impacted by the disease. But despite its success, variolation wasn't a cure-all, and in many cases, that act itself actually spread smallpox within the population. And this was sort of what prompted the search for a better method to prevent the disease. And in the late 1700s, a man named Edward Jenner and many of his colleagues were investigating other strategies for vaccinating people with cowpox as a way to prevent smallpox. So smallpox is a pox virus that exists in a family of viruses that are oftentimes very specific to a species. So you think of chicken pox, that actually originated in chickens. Some can obviously transfer between species, smallpox, chickenpox being examples of those. And then others have their own pox, or other animals have their own pox viruses like cowpox or monkeypox. And so it was sort of common folkloric knowledge that milkmaids who worked in close proximity to cows developed a certain level of immunity to smallpox. And so Jenner experimented upon this idea by actually, systematically studying the possible protection that cowpox virus would provide to smallpox. And so he, in a very ethically different time, he began experimenting on children in his neighborhood. And the first person that he inoculated was his gardener's son, a man named James Phipps. And what he did was he took the liquid from a cowpox lesion and infected the boy with cowpox, and then put him through a variolation process to later infect him with smallpox to see if he had developed immunity to the disease. And so, again, this historical context that only in a society that was so dramatically shaped by disease could this kind of apprentice physician and start injecting kids around the neighborhood with liquid from a cowpox blister on a milkmaid's hand, and then variolate them with smallpox to see if they developed smallpox. So it gives some perspective to how the disease impacted that society and what the push for a cure enabled or allowed people to do. So Jenner self-published the results of his ethically and scientifically questionable study in 1798. And though his peers looked upon his work with some level of skepticism, within about a decade, the vaccination technique had spread throughout Europe and Asia and the Americas. And with its lower fatality rate, vaccination very quickly replaced variolation as the preferred immunization technique for smallpox. Within a few years, by 1801, they estimate that about 100,000 people had been vaccinated in Britain. So a couple interesting things about the vaccination process: they had to extract the vaccine from an active rash, which limited its distribution. So for the first half of the 19th century, the vaccine was actually passed through human bodies, drawing live virus from the blister created by the vaccination itself and injecting it into the next individual. So an interesting example of this, around 1800, there was an expedition to actually bring the smallpox vaccine to Spanish America. And so they set sail with 22 orphans on board, 2 of whom were vaccinated every 10 days in order to keep the virus alive while crossing the Atlantic in order to bring the vaccine to the Americas. And I think this leads to this sort of interesting perception of medical practice during the time period. So by around 1840, they had produced a technique where they could produce large amounts of vaccine in cows instead of on the cowpox on human bodies. And so doctors would bring infected calves into their offices and actually scrape the live vaccine right off the animal's flanks. And so it leads to these wonderful sketches of cows in doctors' offices in high society of Europe, being part of this vaccination process. And I like the photograph, which shows not only how late these live cow vaccines were happening, but also note the bandages protecting the vaccine on the belly of the calf. And I think it's notable that the smallpox vaccine was administered for generations before we ever saw variola virus through an electron microscope. So knowing how to contain the spread of smallpox did not depend upon detailed scientific knowledge of the virus itself, but it depended upon cultural acceptance of medical practices that seemed to increase human survival. And the smallpox question also became a very public platform to kind of negotiate the terms of citizenship in the 19th century. And it raised questions about what governments can and should do to regulate disease in the name of public health and national security, debates that we still see raging today. And over the time, the problem of smallpox vaccine distribution were overcome by new technologies that produced air-dried or freeze-dried vaccines. And they really, as vaccination became more possible, it brought to the surface this quiet hope that the scourge of smallpox could be eliminated from the planet. And the use of vaccine rapidly increased, the abundance of smallpox across the globe decreased, and mandatory vaccination programs eliminated the disease in most countries by the mid-20th century. However, millions of people still suffered from the scourge, and in 1967, the World Health Organization began its intensified smallpox eradication program to eliminate the disease. And the WHO campaign mobilized people to act, to use technology to create masses of immunized bodies and destroy the viable habitat of the smallpox virus. The campaign created that microbe as an enemy to be fought and controlled and eliminated. And the effort established the rights of a modern war against a germ, producing the weapons and strategies and tools and attitudes that continue to characterize health practices today as a battle against invasive pathogens. But managing the smallpox organism required managing human bodies. The fight against smallpox wasn't really a war against disease or even the management of non-human nature. It was a deliberate act of governance that relied on fear and persuasion to create behaviors among populations. Containment depended upon identifying and marking both the source of infection and the immune population. And unlike COVID, you could easily read human bodies to distinguish who was at risk for smallpox. There are no invisible carriers of smallpox. People who are infected have the symptoms on their bodies. People who are immune can prove that they are immune by either showing the scars from the vaccine on their arms or the scars on their body from the disease. So there's a visibility that smallpox had that what we see with the coronavirus does not currently afford. And as the blight of smallpox began to fade, WHO officials, they combed the planet for signs of any other outbreak, and tentatively at first, and then more emphatically, they began to suggest that the disease had been contained. In 1977, a man in Somalia became the last person to catch contagious smallpox from the body of another human being. And his antibodies fought off the virus, and without another vulnerable body to infect, the virus ceased to exist. The chain of contagion had been ruptured, and the 10,000-year-old virus no longer passed freely from host to host. And the decision to declare worldwide war on smallpox could be framed as an act of humanitarian biomedicine, but it was also a decision to destroy another species. And while species extinction is not an uncommon outcome of human, non-human interactions, the purposeful work of the smallpox campaign presumed that nature could be managed to achieve a culturally desired outcome. And I just want to comment briefly on the role of educators in this whole process. And as I've spent a lot of time studying the campaign and looking at the methods that were used and imagining how it would be to live in a remote location in Asia and Africa, which were some of the last places to receive the smallpox vaccine, and to see this campaign convincing you essentially to allow a stranger to take something that looks very much like a gun and put it up against your arm and promise you that that's going to keep you from getting disease. It was a very challenging idea to accept. And we can continue to see this playing out in other campaigns to eradicate diseases. The polio vaccine has existed for a century now, and yet we still see transmission of polio between humans, largely because of a resistance to using the vaccine among populations. So I think there's this incredibly important role that educators play in spreading information, but also helping to combat sort of irrational responses that are deeply rooted in people's culture that may resist the things about these public health campaigns that are obviously very fearful. So one more little bit of trivia before we shift gears here. You would think after the successful eradication of smallpox that we would see a surge of disease eradication. There are actually only 2 infectious diseases that have been successfully eradicated, smallpox being one of them, and the second one being a cattle plague called rinderpest, which is pictured here. There are also 4 ongoing programs that are targeting different diseases like polio and malaria. And in 2008, the WHO identified 5 more diseases as potentially eradicatable. And these will be familiar to those of us who get vaccines in the US: measles, mumps, rubella, lymphatic filariasis, and cystic cirrhosis. So potential there still for more disease eradication, but I always think it's a little bit surprising that we haven't seen more of it despite the presence of vaccines. So a second transformation in history came with the germ theory of disease. Prior to understanding how disease was transmitted, there were a lot of cultural notions around miasmas and bad air. And germ theory really put forward the idea that microbes are everywhere, that microbes are part of our environment. And suddenly disease was external and it could be controlled, and that had very real consequences in the public health system and how we manage disease. So moving forward another century, I want to talk very briefly about germ and the word germ, which originated in agriculture and referred to the emergence of a new organism inside an existing one. So the germ was the being in its rudimentary state, an embryo that was capable of becoming an organism. And this meaning is carried on today, for example, in the center of a wheat kernel, known as wheat germ, right? But it was in the mid-19th century when Louis Pasteur, one of the names that we know and recognize in microbiology history, and others of his time were studying the hypothesis that life spontaneously generates life. They were, of course, looking in decaying meat and fermenting wine, as you may remember from biology classes. And they were seeking the germ of life, the seed that would develop into full-grown maggots or yeasts or whatever they were experimenting with. And it was Pasteur's experiments that disproved the theory of spontaneous generation by showing that germs of microscopic organisms abound, that was his word, abound in the surface of all objects. And he proposed that embryonic microorganisms, invisible to the eye, pervaded the environment, and given the right conditions, could begin to grow and reproduce. A little bit, you can start to see the flaws in his thinking here, but some key ideas come out of it. So by showing that organisms germinate when conditions are appropriate to propagate life, Pasteur also showed that microbes can be destroyed by altering the environments that sustain them. So Pasteur was concerned primarily with environments. He demonstrated that heat could be used to purify food, to pasteurize food, by destroying the microbes that cause the food to rot. He also proposed that microbes were the cause of disease, and that humans could similarly be destroyed by, let me rephrase that microbes as the cause of disease in humans could similarly be destroyed by creating an antimicrobial environment. So it was Pasteur's thinking that led to the great Sanitary Awakening as we go into the next century, where knowing how germs were spread enabled us to socially manage disease. And the rise of sanitation and public health, which was the concept new in its day and familiar to all of us now, that a government has the moral and ethical responsibility to prepare and protect the general welfare of its citizens. And so we see a rise of personal sanitation, people turning to science and technology, emergence of cleanliness products for the home and the individual. This, of course, is correlated with expectations, particularly of the upper class and women, to keep the home clean and prevent disease. And we also see how the individual responsibility was connected to public sanitation. I think it's significant to think about these ideas that carried us into the 20th century and into today. But I want to argue that beyond this sort of attack on the individual, it was really the large-scale sanitation projects that came around the turn of the century that did the most to stem the tide of disease in the population. So I'm going to make my argument. Bear with me, some of my graphs are a little bit outdated because I pulled them from my book and it's getting a little bit older now. But here's a chart showing the improved sanitation in Philadelphia as correlated with typhoid deaths. So you can see the number of typhoid deaths going up the bars, and then some key dates. You see unfiltered water came about in 1902, and then you can see the point where they added chlorine to the water, marked there towards the center of the graph. And in 1906, they made an effort, shocking to me, right, to redirect sewage away from drinking water intake, and filtration began in 1906. And you can see that really dramatic change that improved sanitation had upon typhoid fever and cholera within the population in Philadelphia. And so looking at the sort of the rise of public health and sanitation, along with vaccines, we can see how they have changed the causes of mortality around the world. And I would argue that the current burden of waterborne disease persists today. It's the second largest cause of global child mortality. 1.8 million children die from diarrhea each year. That means 410 children on this planet died during this webinar due to waterborne disease. And over half of the hospital beds in the developing world are occupied by people suffering from preventable waterborne disease. And I think this is an important perspective as we live through this pandemic, to recognize really where the burden of disease exists and the social equity issues at play here. So in looking at, again, a little dated 2000, our distribution of water supply and sanitation, there are 1.1 billion people in developing countries that have inadequate access to water. And our goal is that they would source their water less than a kilometer away from the place of use, and that it can reliably produce about 20 liters of water per household member per day. Access to sanitation, the same story, that we want an excreta disposal system that is private or shared but not public, and it can prevent that interaction with human and animal waste. And just thinking about hygiene practices in general, that access to increased water quantity allows for more frequent hand washing and food cleaning and bathing and all of those things that block the transmission of disease-causing pathogens. And so a really rudimentary illustration of this, that as development increases, as sanitation processes improve, we see a change in mortality rates, where rather than people dying of infectious disease, we see them starting to die of non-communicable diseases in correlation with development. And so just to spell that out kind of in a graphical format, here on the left, you can see high-income countries and what the death rates are. Again, a little bit dated here. Heart disease was recently surpassed by cancer as a leading cause of death in the developed world. But you can see you have to go down a long ways before you get to anything beyond sort of that cancers and heart disease area. Whereas looking on the right-hand side, you can see pretty early on how infectious disease continues to kill people at high rates in the developing world. And so thinking about how we could shift the causes of mortality globally, there are so many things that need to happen, but improved sanitation and drinking water supplies live at the high end of that. Medical advances around vaccines and antibiotics can help with that, along with all of these other sort of social and economic growth systems. But there are so many tools at our disposal as a society to shift these causes, and improving sanitation is right at the top. And we've seen it happen. History shows us how The sanitary movement of the 1800s proved to be tremendously effective. And it demonstrated our social ability to manage health by managing the environment, by managing our bodies. And that was really put to test in 1918 with the Spanish influenza. And I know the influenza outbreak of the early 20th century has been so much in the news lately that I'm not going to really belabor that or go into that at length. But I want to point out that World War II or World War I is characterized and known for the many technologies that it brought, but so did the 1918 influenza. And it really ushered in what I would characterize as the golden age of microbiology. And the golden age, I don't just characterize it that, others do as well. The golden age is really characterized by the surge that was brought on by the 1918 flu and our increased ability to respond to and treat any number of diseases. So the interest in combating Spanish flu brought ideas and minds into the science workforce. And of particular note is the number of women, I think, who were able to enter the microbiology field. Women were excluded from more traditional sciences, but because the field was growing so rapidly and the thirst for disease knowledge was so great, they were welcomed in the new field of microbiology, which I always think is interesting, sort of in that history realm. So, you know, they came into that field and the field really began to change. It was influenced heavily by chemistry, but one outcome of 1918 really was the ability to fight other diseases. We saw the decline of tuberculosis and typhoid and malaria and polio, and people were healthier because of the push in the science field that happened in 1918, and they have been ever since. So a useful thing to think about, what would be the health boost from COVID-19 due to some of these changes. So we have just a few minutes left, and I want to conclude with a case from Hamilton, Montana, which is a town not unlike my own in a remote valley of the Rocky Mountains. And I think it illustrates this kind of quirky work of microbiologists around that time period. And Hamilton was largely an agricultural community around the turn of the century. And it was divided by this river that runs right down the middle of the valley. And in the lore of the day, you were safe on one side of the river, but if you traveled across the river in the spring as the snow melted, you carried the risk of coming back with the black measles or Rocky Mountain spotted fever. And it was speculated, thinking about this history, that it was caused by waterborne diseases, but eventually it was isolated to this little guy. It was a tick-borne illness, and that enabled a public health response that allowed people to take action to eradicate or fight this disease. And so the Public Health Service came in, they set up a lab in this old schoolhouse, and they began a massive public health campaign. It was largely centered around killing rodents who were seen as carriers of this tick, and sanitizing cattle. I don't know if that's the right word. They would run cows through an arsenic vat that would kill the ticks that were that they were carrying on the outside of their bodies. Obviously, it was not popular with farmers because they don't like to bathe their cows in arsenic. And so they continued to pursue other methods and work to create a vaccine. And it really brought laboratory science to this town, and the science itself began to grow. And the laboratory actually wanted to move to another site in town, but it stirred up a lot of controversy because the proposed site was now on the same side of the river as people were living on, and nobody wanted those ticks to be brought across the river. And so people had this sort of geographical understanding of disease that they brought with them in their understanding of the laboratory itself. And there was a battle that went on in court, and eventually the laboratory was built. But I love this quirkiness that they built the rooms in the laboratory with round corners to convey the idea that ticks wouldn't be able to hide in the corners of the rooms. And they actually put a moat around this laboratory to simulate the idea that ticks can't cross water. And they can, hitchhike on your body. It had nothing to do with the water itself, but they reenacted that river around the laboratory itself. And this remote valley became a hub for the study of infectious disease. And there are great stories about sort of that relationship in the town. But in the time, because microbiology didn't exist as a science, you couldn't order microbiology equipment from a catalog. And so this was all about the relationship with the community. They had their own mechanic shop. If a microbiologist needed something to be built, they would go down to the mechanic shop, give them some specs, draw it up, test it out. This is how a lot of our microbiology science was created, was through this close relationship between scientists and the mechanics who were actually building their equipment on site. And the laboratory developed this sense of sort of pride and patriotism for this work to combat yellow fever, which continues today in that community. And I just want to read this little quote at the bottom of the slide, again, playing into this idea of women's roles. And this girl volunteered for a job that is not without peril. From a deadly virus, she prepares a vaccine that protects our fighting men from typhus, the dreadful plague that can cut down an army quicker than bullets or bombs. She works in an isolated laboratory. She is protected by every safeguard of modern science, yet she knows she cannot be wholly safe. So the war certainly brought this new knowledge of microbes and new weapons and ways to increase our scientific knowledge. And because of 1918, we were able to fight tuberculosis, many other diseases that have since been at least fought back, if not eradicated. So some concluding thoughts around panic. As I said before, I don't want to delve in this too deeply about why viruses and microbes are important to us, but I think it is important to recognize that disease makes us who we are as humans. But I think a couple other ideas that because we are invested in studying microbes in this moment, we are more prepared than ever to respond to infectious disease. And while it's devastating to us individually and socially, history shows that strength emerges from pandemic. And a final thought just around beauty, the striping on this tulip is caused by tulip breaking virus, which was the second plant virus to be documented. And it became a prized tulip in the 17th century. So viruses bring beauty and change. And with microbes, what we fear is often not the real risk, that microbes are invisible. They are changing our social interactions, the very things that make us human. And the fear of the invisible is powerful and persuasive. Where I would turn then to our role as educators in just a few of my thoughts, and we have a couple minutes to hear a couple of yours, that knowledge, not just information, really is that antidote to risk. The microbes really are a part of this conversation about nature, that we need to be mindful of it. There's this ability to change minds that educators carry. Polio vaccination will be successful because of strong education among people who are just being exposed to the idea of vaccines for the first time. I think access to youth, inspiring innovation, scientific possibility, and nurturing hope. This tree shows a depiction from over 100 years ago of all of the things that vaccination was going to cure. And 2 of those have been cured off of that entire tree. So educators have this burden, this responsibility to continue to share these ideas and nurture that hope. And a parting thought is as we think about disease, it's so easy to think about it in the terms of an individual, but the key to disease control really came about with our ability to think about our human relationship to our environment. And the key to infectious disease control comes from our ability to think about a population. So COVID seems so impersonal, but that's how we make it a public health issue. And that's the distinction really between a disease and the virus itself, which is so intimate and personal. So I rambled on long like a history professor, but we do have a few minutes left. I'd love to hear some of your thoughts, particularly maybe circling back to this idea of our work and our role as educators in this ongoing crisis and pandemic. So thank you for your time, and I'd love to hear some of your ideas.
Thank you, Melanie. I'm Betsy.
Hi, Betsy.
And one thing that has perplexed me with the COVID virus is that it's dead. How can a dead microbe affect us like it does?
And how does our body continue to react to it over and over and over again in this sort of deadly, violent way? Well, and viruses have that wonderful hybridity in all places, right? Of understanding how they attach to other things and transform them. And I think virologists don't have those answers either. And that's what makes them hard to study. That's what makes them so continually perplexing to us. And that, I remember in my biology classes, it's like, well, we have all these categories of life and then there's viruses and we don't really know where to put them. And I'm like, really? It's been a lot of years and we still don't really have that answer to that. And then, we have phages and viruses that infect other viruses, and it just gets really complicated in terms of that. But I love how that plays with our idea of life too, right? Is something alive? Maybe we don't even know that definition for sure.
Well, it's also curious that COVID-19 kills some people and other people not so much.
Mm-hmm.
Or some people present with diarrhea and other people have headache and temperature.
Mm-hmm.
I mean, it's weird.
And I think that really is what has set this virus apart as something so unique, right? Smallpox was eminently predictable. It was very visible on people's bodies. You didn't really have, non-contagious carriers you didn't have non-symptomatic carriers of smallpox. And so, this is something very unique in terms of how its invisibility can persist even during infection. Mm-hmm. And microbiologists, of course, will look at sort of the ability of a virus to survive by having that perfect relationship with its host too. It can't kill its host too quickly because then it doesn't have time to find a new host to move on to. So it has to have the perfect length of time. And I think COVID has an amazing ability to sort of linger in a body, keep a body alive for a long time in hopes that it can find that next host in order to continue that chain of transmission. Whereas, Ebola kills people too quickly in order to really spread effectively around the globe.
Ebola kill people more quickly than COVID.
Yeah.
I mean, there's only about a week's worth of time.
Yeah, it just happens quickly and you become symptomatic so quickly. You're not traveling through airports carrying Ebola.
Well, I think we have to wrap up there, but as always, Melanie, you were just such a wealth of information. Thank you for sharing your passion and your knowledge on microbes during this time. I really appreciate you speaking again to our group of members here.
I love it. And definitely reach out anytime with questions or comments. I would love to continue the conversation.
Sounds great. And just to let everyone know, we're recording the webinar. So I'm going to follow up with an email with a recording if you want to listen again. And then also I'll be sending out just a evaluation link. We're always trying to improve our webinars. So we'd love to have your feedback. And I'll also share Melanie's other talk that she gave on April 3rd on microbes, since it was really interesting as well, and any other resources that Melanie has for us. But again, thank you all for your time today, and we hope to see you at a future webinar or event. And thanks to Melanie again for your...
Thank you all. Really great chatting.